a small comet deep in our solar system began behaving in a way that didn't make sense. Its rotation was changing far too fast. Its light signature didn't match known models, and for a moment, some astronomers wondered if they were looking at something far more unusual than a simple icy rock. Because this object didn't just wobble, it didn't just slow down, it did something that almost sounds impossible. It stopped spinning and then began rotating the opposite direction. A complete reversal. No collision, no explosion, no outside force, just sunlight. And physics pushed to their limit. Comet 41P is not a giant object. It's only a few hundred meters wide, small by cosmic standards. But during its close pass around the sun, something extraordinary happened. Astronomers track comet rotation by watching how sunlight reflects off their uneven surfaces. As the nucleus spins, brightness rises and falls in a repeating rhythm, like a heartbeat made of light. At first, that heartbeat was simply slowing down. That alone wasn't shocking. When a comet approaches the sun, heat turns surface ice into gas. These jets erupt into space, forming the coma and tail. But they also act like tiny thrusters. Uneven jets create torque, and torque changes spin. But this time, the slowdown was extreme. The rotation period stretched dramatically in a matter of weeks. What should have been a gradual adjustment turned into a rapid loss of angular momentum. Models struggled to explain how such a small body could decelerate so quickly. Then the data became impossible to ignore. After its closest pass to the sun, the light pattern didn't just continue slowing, it flipped. The repeating brightness signal returned, but in reverse order. The only explanation consistent with the observations was radical. The comet had completely reversed its rotation direction. Not tilted, not destabilized, reversed. For the first time, astronomers were seeing clear evidence that solar-driven outgassing had applied enough sustained torque to stop and then flip an entire celestial object in open space. So how does sunlight accomplish something that sounds almost mechanical? It comes down to imbalance. Comet 41P was unusually small and unusually active. Jets were not evenly distributed across its surface. Some regions were far more volatile than others. Each jet acted like a tiny rocket engine firing off center. Individually, these forces are weak, but over days and weeks of continuous activity, they add up. Imagine repeatedly tapping a spinning top in the opposite direction of its motion. At first, it barely reacts. Then it slows. Then it wobbles. Keep pushing long enough, and eventually it stops. Push just a little more, and it spins the other way. That's essentially what happened here. The comet's original angular momentum was gradually drained by asymmetric outgassing. Once its spin rate approached zero, the continued jet activity didn't stop. The torque kept acting, and with nothing left to resist it, the nucleus began accelerating in reverse. A natural propulsion system, powered purely by solar heating, had flipped a primordial object that has existed since the birth of the solar system. This discovery reveals something profound. Comets are not passive frozen relics, drifting unchanged through space. They are dynamic, reactive, structurally vulnerable. Spin rate affects fracture patterns. It controls how dust and gas escape. It determines how stress builds inside the nucleus. It influences how long a comet survives before breaking apart. If rotational states can change this dramatically in a single solar pass, then these objects may be far less stable than we once believed. Some comets might be slowly spinning themselves toward fragmentation. Others could be reshaping their own activity patterns every time they approach the sun. Every close pass isn't just a light show, it's a stress test. So here's the real question. If something as small as sunlight can rewrite a comet's motion, what other slow, invisible forces might be quietly reshaping our solar system right now? And we simply haven't noticed yet? Drop your thoughts in the comments. I'm genuinely curious to hear your perspective. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. Your support truly makes a difference and helps this channel grow. Thank you for watching, and see you next time.